So this is the first video on planes, and we've got a wedge here. So we've got two planes, A, B, E, F, and A, B, C, D. So we've got two different planes here, and they join at the line AB. And it's asking for the angle between the line BE, which is here, and the plane ABCD. So that's asking for this angle here. It's asking for the smallest possible angle, because if I were to take another point on the plane, let's say here, then you might think it was sort of that angle, which would be much bigger. So it's not actually asking for that. It's asking for the smallest angle, which is here. And to find that is just using a little bit of simple trig. So to find the angle here with the right angle with 4 and 2, it's going to involve tan, because this is opposite, that's adjacent. So we know that tan theta would equal 2 over 4, and therefore theta would be arctan, or tan inverse, of 2 over 4, which is a half. And plugging that into a calculator, it should be 26.6 degrees, with an equals approximately 3SF. Oops. Okay, let's have a look at part B, the line BF and the plane. So the line BF is here. Oops. And oh dear, what have I done there? And the same sort of thing, it's asking for the angle between that line and the plane, which would be dropping the perpendicular from F to D to create the smallest possible angle, which is that one there. So how to find that angle? Well, we would need to get the length dB. So at the moment we know, if I label these now, that's D, that's F, and that's B. I'm trying to find this angle here, and I know the height of this thing, EC, is the same as FD, so that is 2. And I need to get now the length dB. And this could be found by just looking at the right angled triangle on the base. It's DAB, and this is a right angle. Well, it doesn't really look like it. It is. And that means I can find the length dB quite easily, because that is 5 from here. It's the same length. And that is 4 again, for the same reason, that's the same length as that one. So then the length dB should just be 4 squared plus 5 squared, all square rooted. And if I've got my calculations correct, that should be root 41. So the length dB is root 41, so dB root 41 there. And I can use that then to find the length, to find the angle DBF. And again, it's using tan. This is a right angled triangle. So tan theta would equal opposite over adjacent, 2 over root 41. And the same sort of thing as before, it's going to be the inverse tan of 2 over root 41, which is 17.3 degrees. Okay. For part C, the planes ABCD and the plane ABEF, and that is actually the same as what we worked out in part A, because it is the smallest angle between those two planes. So the answer to C, which I'll do over here, is the same. It's approximately equal to 26.6 degrees to 3SF. Right. And D, so let's do D. Here. It's asking for the angle between the lines BD and BE. So BD is here, and BE is here. So to find the angle between these two is a little bit trickier. We've got to try to work out our lengths and the angles between them, right? So how should we attempt that? I could just start off by drawing the triangle BDE, just to give a bit of context. So that's D, B, and E. And DB I've worked out before, haven't I? DB was root 41. And BE, did I work that out somewhere? I can't see it. Well, I'll work it out anyway. So it's 4 squared plus 2 squared, all square rooted, 2 root 5. And I'm trying to find the angle between them, which is this one here. I think maybe the best thing to do, I could work out what the length DE is and use the cosine rule. And I can't use any right angle trig like I have before because there's no right angles in this thing. So how could I find the length DE at the back? That's using the triangle FDE, which is right angled, and that has the length 2 for the same reason that is 2. So this is going to be 5 squared plus 2 squared, all square rooted, which is root 29. And I can use these 3 lengths then to find the angle between them. So I could use the cosine rule now, and that would be cos. No, I'm going to do it slightly differently to that. Yeah, okay. So the formula is a squared equals b squared plus c squared minus 2bc cos a. And the first thing to label is that capital A, which is the angle I want to find, which in this case is b. And that means the opposite of that is lowercase a, so that is a squared. To square that would then be 29. And b and c doesn't matter about the order, so b squared is 41, and c squared should be 20. And then minus 2 lots of b times c, which is 41 rooted, times, I'm running out of space here, I'll continue that down here, times 2 root 5 cos a. And by multiplying this out and finding out what cos a should be, it should turn out that cos a would equal 32 over 2, oops, I'm running out of space. Okay, I'll do it over here. So cos of a should be root 32 over 2 root 820, and I've got that by just manipulating all this stuff. I've skipped a few steps here because of space limitation, and then finding out what a should be, I have to do the inverse cosine of both sides, leaving that to be 56.0 degrees to 3SF. Okay, next example.